Hi there, this is Waves Lesson 3, and this is introducing the EM spectrum, or the electromagnetic spectrum. Objectives then are simply to list the EM spectrum in order of energy, frequency, and wavelength, and also to learn some basic properties of electromagnetic waves. Alright, let's move on. So first of all, start a question from Lesson 2. So if you want to have a go at this one, if you want to pause. If you can't remember the equation, I'll write it down now. If you can remember the equation, obviously, pause before I do it. So the equation is the wave speed equation, which is wave speed V is equal to frequency times wavelength. And we want the wavelength, so let's go through this then. So wavelength would be, so we'd have the speed V, and we need to get rid of the F, so we're going to divide through by F, because dividing by F is the opposite of timesing by F, so that would be wave speed divided by the frequency. So the wave speed, now if you've done standard form, I'll do it standard form way first, you can simply just write 3 times 10 to the power of 8 in your calculator, divided by, this is 100 capital M, which stands for mega, and then hertz, so 100 mega means million, so that will be 100 times 10 to the power of 6, and then put that in your calculator. So that will give you 3 meters. If you've not done standard form yet, or you're not comfortable putting that into your calculator, 3 times 10 to the 8 is 3 with 8 zeros. Divided by 100, now mega, you still should know that that means million, so you would write 100 million, which is 6 noughts. Put that in your calculator, and you obviously end up with the same 3 meters for the wavelength. Okay, let's move on. So the EM spectrum, the electromagnetic spectrum, now the bit that we should all be familiar with is visible light. That will be definite, as we use that every day, obviously to see things. And then if you go to the right, you get ultraviolet, X-rays, gamma rays. The bottom bit, the numbers 10 to the 3, 1, they're all the associated wavelengths, the lengths of the waves. So you got infrared radiation to the left, microwaves, and then radio waves. And what you need to be able to do is to list them in order, but in order of wavelength, frequency, or energy. So we're going to look at that now. So the EM spectrum, electromagnetic spectrum, is divided into 7 bands, which in order of decreasing wavelength are, so you've got radio waves first, and then decreasing wavelength, the wavelength obviously gets smaller. So it's microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. There's a song on YouTube, if you Google the electromagnetic spectrum song, some guy from Taiwan. It's really old and really corny, but it's pretty good. Your teacher will probably play it in lesson at some point. But anyway, there they are. If you want to pause and get that down. All right, I'm going to move on. So this time in order of decreasing frequency and energy. So if you did it backwards, started with gamma rays, X-rays, UV, visible light, infrared, microwaves, radio waves. So basically gamma rays have got the highest frequency, radio waves have got the lowest frequency, and gamma rays have got the greatest energy, and radio waves have got the least energy. In terms of wavelength then, if you want to add that on, the gamma rays have got the shortest wavelength. I'll just write short lambda, shortest wavelength, and the radio waves, they have the longest wavelength. So make sure you've got that. All right, let's move on. So we need to know some common properties. So all electromagnetic waves, including visible light, have the following common properties. So they all transfer energy. They're all transverse waves. So we did that in lesson 1. They all travel at the same speed in a vacuum, which is 300 million meters per second, or 3 times 10 to the 8 meters per second. It's also approximately the same in air, so we use that value in air. They can all be reflected, refracted, and diffracted. So reflected, you'll probably know what that is. Refracted means to change direction as it enters a different substance, and diffracted is to spread out. So we'll look at those in these series of lessons as well. So some notes, just to give you some perspective. The 300 million meters per second is the equivalent of travelling at 186,000 miles per second, which is obviously pretty fast. So through air, light and other waves travel at about the above speed, but through denser substances, for example glass, the speed will be reduced. So glass is like 2.2, 2.3 times 10 to the 8 meters per second. So it's a little bit slower, still fast. And according to Albert Einstein's theory of relativity, nothing can travel faster than the speed of light through a vacuum. We've tried to find things that travel faster than light and been unsuccessful. So it's like the ultimate speed limit of the universe. There is a subatomic particle that travels at the speed of light, and it's called a neutrino. You'll learn about them when you do A-level. Or you can Google it and find out. Anyway, make sure you've got all that, so if you need to pause, please do so, and then let's move on. So if you want to complete this, so you're going to pause. I'd advise you try not to look at your notes, or you can pause, look through your notes, and then try to do the answer. It's completely up to you how you do it. So I'm going to go through the answers now. So highest frequency, so that'll be gamma, and then X-rays, UV, visible light, infrared, microwaves, and radio. Radio's got the lowest frequency. Then we'll go the other way, so the longest wavelength will be radio waves, then microwaves, infrared, visible, UV, X-ray, gamma, and then the greatest energy again, same as the first one, gamma, X-rays, UV, visible, infrared, microwaves, and lastly radio waves. Right, so let's finish with a word fill exercise, closed exercise. So if you want to have a go at it without the keywords, if you want to pause and do that now, I'll put the keywords on in a second. I'll put them on now. And then I'll take you through the answers. So unpause when you're ready. So the electromagnetic spectrum is a group of waves that are divided into 7 bands. Gamma rays have the shortest wavelength, highest frequency, and energy. The rest of the spectrum in order of increase in wavelength are X-rays, UV, visible light, infrared, microwaves, and radio waves. All electromagnetic waves travel at the same speed through a vacuum, and that's 300 million meters per second. So that's the introduction to the electromagnetic spectrum. I hope you found that useful. And in the next lessons, lesson 4 and 5, we'll look at the uses of the electromagnetic spectrum. All right, thanks for watching, and speak to you soon.